Okay, good morning, good afternoon, good evening, or good night, depending on when you're watching this video. We are going to work through slide 22 from lecture set number 2. This slide is meant to give you a number of different examples of common distributional shapes. So the build up to this slide was the discussion on quantitative data and visualizing quantitative data using a histogram. Now, different data sets are going to produce different histograms, and those histograms are going to have different shapes. And we describe the shape using the modality and the skewness or symmetry. We have seen on the previous slide, slide 21, an example of a symmetric and a skew distribution. So we can illustrate those in a more general context here. So suppose that we label this as the center, so this is the midpoint. A skew distribution is evenly distributed about the center. So the peak, the modal peak is right at the center point, and on each side of the center, we have roughly the same amount of information. Right? Okay, now we've also seen an example of a right skew distribution. With right skewness, we have the peak to the left of center, and then we have a skew tail going to the right. So remember that skewness is always defined by the direction of the tail. So we have symmetry in the first example. And we have right skewness in the second example. So we're skewing to the right, okay? All right, now we can skew to the right or we can skew left. So the next common shape would be left skewness. Okay. So in this case, we'd have the same illustration, but just kind of a mirror image as right skewness, except now the peak is on the right side, but the tail is skewing to the left. Right? This is left skewness. So those are the three common unimodal shapes. Again, unimodal because we have one mode. There's one peak on each of these diagrams. And what we have done is we've distinguished between direction of skewness, right versus left skew, where skew is tail direction. And then we also have the symmetrical unimodal curve, which starts it off. And that's kind of the basis for everything. Now, there's a lot of other distributional shapes that you could observe in practice. So another common shape that you might observe would be a symmetric bimodal shape. So bimodal meaning two peaks. So we might have something that looks like this. Okay. So here we have symmetric bimodal. Now with multimodal distributions, or we can also have other multimodal distributions. So perhaps our next example, we have something like this. All right, so now we have roughly a symmetric trimodal distribution. Okay, so this would be trimodal. We have three peaks. All right, we can skew, or we can observe skewness with multimodal distributions as well. And again, skewness is just going to be indicated by the direction of the tail. So for example, here, let's consider a bimodal distribution, but it's right skewed. All right, so we might observe something like this. So this would be right skewed bimodal. All right, and then you could also skew to the left. So maybe in that case, we observe something like this. It's unlikely the peaks are always going to be at the same height, but just for illustrative purposes, here we would have a left skew and we could use a general term like multimodal, but I guess that this would be quad modal. Okay, so left skewed, quad modal, we have 4 different. All right. So most often throughout this course, we're going to be concerned with number of modes, right? So unimodal, bimodal, sometimes trimodal. Very rare we're going to see more than 3, but you're just counting the number of peaks. And then direction. And again, skewness is the direction that the tail runs. There are some other common shapes that may occur throughout the lab in the semester. So if you observe a rectangular shape, sort of like this, you can draw that a bit better. So something like that, this would be called, we call this the uniform, okay? You could also observe something that looks like this, though it's very uncommon. And this would be an example of a triangular shape. Notice that both of these are symmetric. Yeah, and those would probably be about as obscure as we'll see at this level. Okay, so these are, again, the big takeaways from this particular slide are direction of skewness and number of modes. So we're counting the number of peaks on a diagram, and then the direction of the tail determines the direction of the skewness. So the skew tails in these top 2 examples, this is going to the right, and this is going left. So we label according to that direction. As always, let me know if you have any questions.